This video will present solutions to the 2018 VCE Mathematical Methods Written Examination 2, Section B, Question 5. Question 5. Before I start working through this question, I'm going to define the functions f of x and h of x on my class pad. Part A. The function f of x is a cubic of the form minus k x squared by x minus a. As such, it will have roots at the origin and at x equals a, and will look something like this due to its negative leading coefficient. The stationary points of f of x can be found by solving f dash x equals to 0. So we have solutions x equals 0 and x equals 2a over 3. This provides us with the x coordinate of our maximum value. The y coordinate can be found using the function. So our local maximum is x equals 2a over 3, y equals 3 over a. Part B. The x coordinates of the intersections of f of x and h of x can be found by solving f of x equals h of x. These solutions are x equals 0, a on 3, and 2a on 3. Part C. Based on what we know about f of x and h of x, a sketch would look something like this. This is because the graphs intersect at the maxima and minima of f of x, as well as at a point in between. Therefore, the area between the functions is given by the following integral statement. And this can be evaluated on our class pad. This provides us with an area of 2/16 or 1/8. Part D. We are now considering g of x, a function with the same rule as f of x, but with a restricted domain. Using information provided previously, we know that g of 2a over 3 is equal to 3 over a. We found this when we found the local maximum of f of x. As such, our calculation is equal to 2a over 3 multiplied by 3 over a. This can be simplified to 2. Part E. We are asked to find an area that looks something like this. This is equivalent to the area between g of x and the y-axis. And this area is equal to the area of the rectangle bounded by x equals 2a over 3, subtract the area under g of x, i.e. the rectangle minus the integral from 0 to 2a over 3 of g of x dx. From part D, we know that 3 over a multiplied by 2a over 3 is equal to 2, giving us the area of our rectangle, 2, and so we can calculate the area required on our class pad. Giving us an area of 1. Part F. Thinking about the sketch we drew in Part E, g of x and g inverse have endpoints 3 over a, 2a over 3, and 2a over 3, 3 over a. And so for these to be equal, we need to solve 2a over 3 equals 3 over a, implying a squared equals 9 on 2, and a equals plus or minus 3 on root 2, or plus or minus 3 root 2 over 2. As a is greater than 0, a equals 3 root 2 over 2. The same solution can be obtained on our class pad. If g of x and g inverse have the same endpoints, then their graphs will look something like this. This is the line y equals x, g of x, and g inverse. The area between these two graphs will be twice the area between g of x and the line y equals x. The endpoints required for our calculations will be a over 3 and 2a over 3, but as a equals 2 root 2 over 2, these endpoints become root 2 over 2 and 2 root 2 over 2, or root 2. So the area required will be equal to 2 multiplied by the integral from 0 to root 2 over 2 of x minus g of x dx, plus the integral from root 2 over 2 to root 2 of g of x minus x dx. giving an area of 2 multiplied by 1 over 16 plus 1 over 16, which equals 4 over 16, or a quarter.